go. Okay. Put Z1 on the graph. Z1 is what, guys? 2 across and 1 up. So, would everybody agree that, oh sorry, 2 across and 1 up. We already went 2 across and 2 across, 1 up. Everybody happy with that? That's Z1. Now, Z1, as we know, goes across 2, up 1. Happy days, right? Now, where's Z2? Anybody? 4 to the left and 3 up. Okay? Now, from a visual perspective, what do you think Z2, what do you think Z1 plus Z2 looks like? Anybody know? You don't have to draw the lines, by the way, they're just there to show what's going on. So Z1 plus Z2, do you know what that means? Go Z1 and then do the same distance with Z2. So you can do it graphically as well. Across 2, up 1, and now what do I do? Across 4, up another 3. Across 4, up another 3. And right there, that would be, that's Z1 plus Z2. You could just add them together, couldn't you? What's 4 take away, 2 take away 4? And then what's I plus 3i? Does everybody see it's at the point minus 2? 4. We all good with that? Alright. So that's what happens when you add them together. Just means you do one of them followed by the other one. Okay. Conjugates are really handy as well. So I'm going to do the conjugate of Z1 and the conjugate of Z2 in a second.
Sorry for disturbing class. Could we ask?
Alright guys. Quiet please. Shh. Alright. Lads. Shh. Next thing. What does the conjugate do? Well, conjugate actually has a special role in the geometry here. So if you have 2 plus I, what's the conjugate? And what's the location of 2 minus I? Can anybody tell me what does a conjugate do? Mirror image in the real axis or the x-axis. Is that right? What about the conjugate of Z2? Where do you think that's going to be located? 3 down and another 3 down. That's the conjugate of Z2. We alright with that? Alright. The rest of the equations are you'll either multiply them out or do the conjugate thing and you'll get an answer and you'll plot the answer. Is that alright? There's no other special tricks that I can show you here. Right, so we'll move on from question 2. Alright, question 6. I like question 6, it's a good one. Right, and it shows the effects of multiplying by I. Okay, so paste. And this works for all of these, right? So, where's 3 plus 2i? Anybody 3 plus 2i? Everybody happy that's Z? Now we're going to get IZ. So I multiplied by 3 plus 2i. Any takers? 3i plus 2i squared, which is? Minus 2 plus 3i. Okay. What about I squared? 3 plus 2i. What's I squared? And then after that, minus 3 minus 2i. And what's that? I squared Z. You alright with that? Now what's the next part? I cubed Z. Now what is I cubed? You remember it from yesterday? I cubed is I squared times I, which is minus I, isn't it? And what's minus I times that? Minus 3i minus 2i squared, which is 2 minus 3i. Okay. Does anybody notice anything in the patterns? Huh? Alrighty. Okay. First and foremost, they're all the same distance from the from 0, 0. Second thing, they are, whoa, the wrong choice. They're all pitched at 90 degrees to each other. 90 degrees there, 90 degrees there, 90 degrees there. So, be quiet please. Now guys, the effect of multiplying a complex number by I is a 90-degree anti-clockwise rotation. So 90 degrees anti-clockwise rotation, alright? But while we're at it, there's sometimes a mix-up about what happens if you multiply by minus I. And people rightfully think it's going to result in a 90-degree clockwise rotation. Wouldn't you assume that, wouldn't you? Some people would. Alright? So, here's what's going to happen. Are you ready for this? So, minus I, I'm going to go through minus I, I'm going to go through minus I squared, and then I'm going to go through minus I cubed. And we're going to see if it has a similar effect to what it is here. Everybody cool with that? Let's find out. What's minus I times 3 plus 2I? Minus 3I, minus 2I squared, and then 2 minus. Alright, so far, multiplying by minus I has sent this in a clockwise direction of 90 degrees. So far, it looks like that assumption actually works. Is that right? So, how would I convert this answer into minus I squared? I could just multiply it by minus I again, couldn't I? And what happened then? Minus 2I, yeah, plus 3I. Alright, and what's it become now? Where's that? Damn, we've gone 90 degrees twice. Alright, let's go again. Multiply it by minus I another time. What am I currently on? Minus I cubed. Is that alright? Now, minus I cubed. So, let's go. I'm multiplying it by the answer. So, what's that? 3I? And then plus 2I squared, yeah, and then alrighty. We're all the way up here now, aren't we? Looks like it's about to work. The last one. Multiply by minus I. What we get? 2I minus 3I squared. And long behold, it sent us all the way around. So, you would be right if you said multiply by minus I. Happy days. That's where you check stuff. Now, there is a catch, alright? And here's the catch. Everybody ready for this? What is the big difference between, example, what's the big difference between minus I cubed multiplied by a complex number or minus I cubed multiplied by a complex number? What's the massive difference there? Usually the minus sign, if it's not in brackets, it can affect the way you're going. So you have to make sure you multiply by minus I every time. So if I gave you a question like this, minus I to the power of 5z, you'd have to treat the minus as separate, wouldn't you? So it's technically minus 1 I5 z. So you do I5 z first, and then you multiply your answer by minus 1. But if I gave you this question, alright, Oscar? If I gave you this question, if I said minus I, sorry, if I said minus I to the power of 5 times your complex number, then that answer might be slightly different. Actually, the answers are different when it's an even number. So there's a big difference between minus I to the power 4 z and minus 1I to the power 4. The two of them actually come out completely. See those two there? They come out completely differently. The odd numbers, they're actually the same, but for the even numbers, they're completely different. Is that okay? So just keep an eye on that when you're doing these questions. Alright. So to sum up, multiplying by I rotates you 90 degrees anti-clockwise. If you multiply by minus I every time, you're going to go 90 degrees clockwise. Alright. Let's keep going. Alright. So, paste. Deadly. Alright. 2 plus 5i, where's that located? Anybody? 2 across and 5 up. Alright. Now, does anybody know what a modulus is? Modulus? So, if I said the modulus of Z1, see the way I have it in the two vertical lines? You guys know what the two vertical lines mean, don't you? Either means length or can't be negative. So, if I did Pythagoras' theorem, I'd get the answer pretty quickly, wouldn't I? What's the it's just going to be 2 squared by, what's it? 2 squared and 5. Now, for all complex numbers, it's the real part squared plus the imaginary part squared. So what's the real part? Anybody? 2. What's the imaginary part? 5, just the 5. Not 5i, just the 5. In the same way you do Pythagoras' theorem, isn't it? And the answer would be root. Everybody happy with root 29? If you take down that formula there, square root of real squared plus imaginary squared. That's for the, it basically gets the length of the complex number. So this complex number Z1 is square root of 29 away from the origin. Huh? I am imaginary. Alright. Next question. Can anybody make up another complex number that has the exact same distance away as that complex number right there? Any takers? Go on, Phelan. What? Yeah. Phelan's going to go for 2 minus 5i, which is this one here, isn't it? So 2 minus 5i would have the same length away from the centre. What about another one? Minus 5 plus 2i. Any other ones? What about here? What's that one? There's another one. There's tons of them, isn't there? You just have to make sure you use 5 and 2. I think there's 8 of them. 8 different lengths you could, 8 different numbers you could use. Is that alright? Cool. Let's move on. Oh, lovely jubbly. Alright. Mr. Clear, pick a letter. Alright. Pick another letter. Very inventive. Now, is everybody happy that Z is xi plus yj? Everybody cool with that? Oliver, what's the conjugate of Z? Sorry. I just got stuck in applied maths mode for a minute. It's actually x plus yi, and then therefore, what's the conjugate? Everybody on board so far? Cool. Right. What's the modulus of Z? So you got to square the real and square the imaginary. What you get?
X squared plus y squared.
Yep. What's the modulus of the conjugate? Huh? And what is x squared plus minus y squared? Have I proved that the modulus is the same no matter what? We saw that earlier, that the conjugate and its original are always going to be the same distance away from the 0, 0 mark. Jamie? Complex numbers. Set is an element of complex numbers. So set element C is set element of complex numbers. This is our class pretty much over, isn't it? So I did 13, 8, 13, 6 and 2. 2, 6, 8, 13.